This lesson is for anyone who was absent on Thursday or Friday when we learned how to write a quadratic function in Vertex form. You can see the PowerPoint that I have here, which can also be found on Canvas. If you look there, you are taking a quadratic, which would be of the form, let me write it up here, standard form, y equals ax squared plus bx plus c, and rewriting it in vertex form. We're going to learn how to do that. It involves completing the square as part of the process, and I'm going to do 2 examples below, as well as teach you a shortcut to graph that would not require you to make a table of values. The beauty of vertex form is that if you can identify the vertex, which would be the values h, k, and the value of a, you're going to understand how to graph. As far as the other things you see there, the axis of symmetry is still the vertical line that passes through the vertex that divides the quadratic function or parabola into 2 symmetric halves. And then the value of a, the absolute value of a, because a quadratic can either open up or down, the value, if it is bigger than 1, for instance, the absolute value of either positive or negative 2 is 2, which is larger than 1, will mean that the graph will be narrower than the parent graph, y equals x squared. Remember, on the parent graph, we have the origin, and then we have the points positive 1, 1, and negative 1, 1, and positive 2, 4, and negative 2, 4. Well, if the value of a, its absolute value, is larger than 1, as it would in the case of positive or negative 2, what's going to happen is the parabola is going to go over 1 unit on either side of the vertex and up the value of a, which we're going to learn that in a couple minutes, but that would mean you're going up 2 units instead of 1, which is going to make the parabola open narrower. On the other hand, if the absolute value of a is between 0 and 1, for instance, positive or negative 1/2, you are going to go over 1 unit from the vertex on either side, but only up a 1/2 unit, which means the graph is going to open wider than the parent graph. So that's just kind of giving you an idea about how wide the parabola is going to open. Vertex form, let's move down here. I have a problem which says here, let me get my pen in the right color. It says write the quadratic function in vertex form and graph. So how you do that is you start by taking the quadratic and grouping together the variable terms, which in this case is x squared and 6x. You leave space to complete the square, and then the constant term is outside by itself. It does not want to do anything with completing the square. It is kind of shunned by itself outside the parentheses. Now, as far as completing the square, we of course look at the value of b, which is 6, and we divide that value by 2, and we square it. Well, 6 divided by 2 is 3, and when we square 3, that would be 9. So that would be the value that completes the square. When we solve equations by completing the square, of course, we add that value to both sides of the equation. Of course, here, we want to leave y by itself, so what we're going to do, instead of adding it to both sides, is we're going to undo what we did on the right side. If I add 9 to complete the square, since I want to keep y by itself, I'm going to subtract 9 outside the parentheses to make the right-hand side the same, regardless of what value I completed the square with. So now, I can go to vertex form because I created a perfect square trinomial, which gives me those two identical factors of x plus 3, and then the plus 2 minus 9 would be negative 7. That means my vertex is going to be negative 3, negative 7. Remember, standard form is x minus h, so this really would have been x minus a negative 3, quantity squared, which is why the vertex is negative 3, negative 7. The value of a, that is actually implied here. It doesn't change from standard form to vertex form. That value is 1 above, so the value is 1 in vertex form as well. And because a is positive, we know our parabola opens up. So to the right here, I've made a little chart. This chart is going to help you graph without having to make a table of values. Could you still make a table of values and put the vertex in the middle and test 2 points on either side that are equidistant? Absolutely. It's just that takes time and work, and the shortcut is going to save you time, and so it's good to learn the shortcut, and I've kind of made a table of values. So, not a table of values, a table to help you understand the shortcut. The over and up is because we know we open up, and over is the number of units you're moving on either side of the vertex. So my table suggests that if you move over 1 unit on either side of the vertex, you would have to move up that distance squared. That's because it's a quadratic and x is squared in a quadratic. So you'd move up 1 squared times the value of a. Well, 1 squared is always 1, times a will always make that value become a. When you move over 2 units on either side of the vertex, you would go up 2 squared times the value of a. Since 2 squared is 4, that means you always go up 4a. Usually, that's going to be enough points to graph your parabola because you'll have your vertex and then 2 sets of symmetric points on either side. But just so you understand this pattern continues, if you were to go over 3 units on either side of the vertex, you would go up the distance 3 squared times a, which would be 9a. So I'm showing you in black for this parabola, since we know a is 1, I would go over 1 unit on either side and up 1 unit. Let me actually do that here. So I'm going to go and graph my vertex at negative 3, negative 2, 4, 6, 7. That would be there. And when I go over 1 unit, I'm going to go up a, which is 1, and I'm going to do that on both sides of my vertex, horizontally over 1, vertically up 1. So that gives me those 2 points. Now I'm going to go either side of my vertex because I go back to my vertex, I go over 2 units, and I'm going to go up 4a. 4 times 1 is 4, so I go over 2, up 1, 2, 3, 4, and I put that point. And I do that on the other side being symmetric. And I don't need to because that's 5 points, but if I wanted to even do that again, 3 would mean I'd go up 3 squared or 9a, and 9 times 1 is 9, so if I went over 3 units, I'd go up 9 units. Since I'm 7 units below the x-axis, that means 2 units above, so that actually put my y-intercept, which I know my y-intercept up in standard form is positive 2. That makes sense, and over 3 up 2. So that just shows you how you get those points, and that saves you making that table of values. And so now I've graphed my parabola. Should be a little smoother down at the vertex. All right, so that's our first example, and I'm only going to do 2. You can look at the hard copy examples on Canvas, but hopefully this will help you enough to understand. So I'm moving down now to my example 2. So I'm going to start by factoring out the value of a, -2, from only the variable terms. Now, when I do that, x squared is easy, but when I do that for the positive 8x, that's going to change my operation to minus, because a -2 times a -4 would be positive 8, and then, of course, the x, and then I'm going to have a -5. I want to find that value that completes the square, so I'm using the -4, and I would take -4 divided by 2 squared. Well, -4 divided by 2 is -2, squared would be +4. So I'm going to add 4 here. Now, it's complicated by the fact that it's really not a +4 if there's a -2 that's been factored out. That's really a -8. So technically, we should be subtracting 8 out here. That means I have to do the opposite, or add 8. So what I would do is not actually subtract the 8, but I would do +8 here. Now, I'm going to show you, some students don't quite get that, so I'm going to show you something. This is the first year I'm trying it, but I have found this helps some students. So to be universal, what you could do if you didn't want to do it in one step is you're adding that 4, well, you're going to have to subtract, and then you would take what you have for the value of a, which is -2, times that +4 that you just completed the square with. And you're going to see that that is another way of helping you understand that what's happening here when you complete the square with the +4 is that that becomes +8. And again, that's because -2 times +4 is really -8, so we've got to add it. Either way, it's your choice of how you go about doing that. So now we're going to go to the vertex form. Y equals -2 times, this would be the quantity x minus 2 squared, and then -5 plus 8 would be +3. So our vertex here would be 2, 3. The value of a is -2, which means our parabola opens down. And I've already made my chart, you know, with the over 1 down a, that's going to be over 1 down 2. And when I go over 2, I'm going to go down 4a, which for me, that would mean over 2 down 4 times -2, which is -8. Oops. So graphing. I'm going to graph my vertex at 2, 3. On either side of the vertex, I'm going over 1 unit, down 2. And then from my vertex, I'm going to go over 2 units, down 8. So if I'm 3 units above the vertex, I want to go 5 units below it because of symmetry, same distance. And now I can draw my parabola. That's it. That's vertex form. And it's a nice shortcut to understand with the squaring effect because it saves you making a table of values. If you look below, this homework can be found on Canvas, but you can see I've assigned just 8 problems. On page 278, number 9, don't do 10, it's a bear. Skip 10, 11 to 14 all. Then on 285, 1 to 3 all are going to be quadratic inequalities. You're still doing the exact same thing, writing the quadratic in vertex form, graphing, but when you graph the curve, it might be solid or dotted, depending on the inequality symbol, and then you will want to shade, similar to what you did with linear inequalities. Greater than or equal to is above the graph, the curve, less than or equal to below. You can always use a test point to check yourself. I hope that helps, especially if you are gone, and we'll go from there. All right. Thank you.